Hi, I'm Cliff, and this is my garage. After thinking about it for several years, I finally bought myself a 3D printer. Hey, welcome back to the garage. And if this is your first time joining me, thanks for dropping by. Now, as I said, I've been looking into 3D printing for several years at least now. But I've started up multiple small businesses over the last 25 years as an entrepreneur. And my latest one is what I like to call a micro manufacturing company. We make limited runs of many different products, and we sell them on Amazon and a couple other marketplaces. And a few products that I've got in mind would lend themselves to 3D printing, I believe. And so I've been looking at a way to kind of ease into the area and do some experimentation and learning. And then once we've got our processes down, then we'll invest in much more expensive 3D printers to actually do our final production for the products. So I've been looking into the printers and just nothing really seemed to fit the bill of what I wanted as just a starter system. I didn't want to spend a whole lot of money, but I wanted something that wasn't going to be overly complex or hard to learn how to do the 3D printing process. And I finally, earlier this summer, came across the Creality CR-6 SE Kickstarter project. And this was really kind of interesting because it seemed, well, Creality has a long history with doing 3D printers. They have a very good reputation. And this one seemed to be a fairly good machine. It seemed to be a mature product or potentially a mature product, considering that it was a Kickstarter, and also a problem that a lot of 3D printers seem to have, and I mean people running 3D printers, is problems with leveling the bed of the printer. And this system has an auto leveling bed. So that really caught my attention. And the price was really dramatically inexpensive. I was in not early in the process. In fact, I was number 1,000 out of 1,000 for the level of, what's the word that they use? Not support. What is it? The level of funding. I can't remember the phrase that they use, but for the level of funding I went in at, I was number 1,000 out of 1,000, and I paid, I'm pretty sure, $340, shipping included, for delivery in August. So the printer arrived yesterday, and I'm pretty excited about starting my journey. But it was a Kickstarter, and so one of the things that, could potentially go wrong has gone wrong. I got an email from Creality on the same day my printer arrived, and it basically said, well, we've identified a problem. It's not a user problem or a user error, and we're working on a solution. We should have one within a few days. And oh, by the way, don't let your printer run all by itself. Hmm. Okay. Just Creality in the future, it might be a good idea to explain why you don't want to leave it. I mean, is it that it kind of messes up, that it stops printing, that it goes haywire, that it bursts into flames? What is the problem? Well, after doing some reading on some other forums and checking out some news, it turns out the problem is that it can burst into flames. Okay, well, maybe not burst into flames, but there have been reports of them like emitting smoke when you turn them on. And at least a couple people claim that theirs actually did catch fire. So we're still going to go ahead with this. We're just going to be a little extra careful, and hopefully within a week, Creality will have an answer for me. Now, because of this issue, I'm going to do something that I normally wouldn't do. I'm going to go ahead and unbox this, but in the process of doing that, I'm going to actually disassemble part of the machine. I want to look at the electronics. I want to examine the switch because the switch sees maybe that's where the issue's at. And I want to make sure that all the connectors are solidly on. Everything looks well crimped. I don't see any obvious, short circuits or anything like that. And hopefully all will go well. And I am not one of those people who's going to let the magic smoke out of the machine. So our plan for the day is to unbox the machine, make sure all the parts are here, look inside and check for any bad connections or anything, and then put it together and give it a test run with one of the sample files that they provide. Okay, let's cut into this thing. Alrighty, and okay. First thing I really like, I'm looking here and they're using a high density foam as the packing material. I hate opening a box and it's that expanded polystyrene, the white stuff that breaks up into all the little balls and makes a huge mess. Thank you, Creality, for not using that stuff. All right, so we have a user manual. We have a caution. Use Creality slicing software. Okay. Unfortunately, I believe that the Creality slicing software is Windows only, which as a dedicated Mac user, I don't like, and I will avoid a Windows machine as much as possible. The only Windows machine that I own is one that I specifically need to run a particular piece of diagnostic software for my Porsche Cayman. That's it. Okay, so we will just, there's some other stuff about how to do a something about G code. I don't know. We'll look into that a little more deeply later. All right, we have, is this, still don't know what this is. Goodness, very hard. Oh, it is a spool of filament. Seriously, Creality, you couldn't give me something other than orange? I mean, really. Black, white, gray would have been fine. Orange? Okay, that looks like that is the LCD control panel. That is probably the filament spool or spool holder. Power cord. Not going to catch fire on me, are you? We got here some bolts and screws. Handle goes on top. One thing that's kind of nice is the CR-6 SE is designed to be carried around. It's designed to be portable, so that's why it has its own handle. Let's see, that's the second layer. What we got here? This is the rest of the spool holder. That goes with this, I think. Yes. Okay, a lot of little nooks and crannies here. Kind of hard to tell. No, that's another layer. Okay, I think we're done with that layer. I'm assuming this comes up. There we go. All right. Okay, there's something I'm kind of surprised at. Let's see if you can see this right here. Let me use a flashlight to highlight that. This padding around what I guess that's one of the that's one of the stepper motors. That's not much padding at all. That's only like I don't know, 3/8 of an inch or so. That seems like that's not a particularly good packing decision. Hopefully that doesn't come back to bite us. Let's see what we got here. I don't know. This is not coming out. There we go. All right, looks like we've got some spare nozzles, some sort of a electrical connector, and this is looks like that's the filament tube, or the guide tube, or I forget exactly what it's called. Noob. All right, I guess. There we go. Sure, I'm supposed to get this out of here. It looks like. Oh, okay. This tube was caught on a piece down here. All right, this is the gantry, or what I believe is called the gantry, that sits upright, and there's the extruder right there. Let's carefully set this aside. And kind of hard to see exactly how I'm supposed to grab this and lift it out of here. Pull this padding out. Okay. Ah, okay. There we go. What's the front and what's the back? All right, looks like this is the cable that goes up to the gantry. Just trying to check out the motion here. It's hitting a couple of stops. It's not super smooth. A couple of, almost like it's hitting a depression. Seems like it would go over that. It's going to make it stutter. What exactly is going on there? Hopefully I'm just over concerned because I just don't know what I'm talking about. I see several loose connectors. Ah, okay, they're taped down. The connectors are taped down to the bed here. I'm sure the assembly instructions will tell me what to do with those. I sure hope so. Let's look here in the manual, see if they give us a list of what should be in here. Okay, I see just parts identification. Ah, parts list. Okay. Maybe I should have looked at this first. Base frame, got it. A gantry frame, okay. Display rack, all right. Handle, spool, power cord, saw that. Filament, ugly orange filament, yes. Okay, and then didn't see, oh, wait a second, that's right. There is a, okay, where's the front? Is this the front? This is the front. Okay, here's a drawer. Apparently this has been a point of confusion for some people. They think stuff is missing. It's actually stored in this drawer in the front of the machine. Okay, a little spatula thing to pop things off the build plate. Couple of stickers. That is that needle, that is probably to clean out the nozzle, I'm guessing, if it clogs. We got some Allen wrenches. I'll avoid using those if all possible. Got a pair of tiny, tiny clippers. Okay. Some sort of a wrench. And now that I'm thinking back to it, this reminds me of an acupuncture needle. Hard to see. Got a little wrench. There's the SD card, 8 gig SD card. It stores what I believe are some sample files, both objects and already processed down into G code. That's what I'm going to try and run as my first test. This is a USB drive. Don't know what's on that. And a bag with, looks like a couple more nozzles. Maybe a couple little plugs and wire management things. Not sure. Okay. I'll kind of pile these back up onto the tray. So if it tells you something's in the tray, I'll know where that's at. All right, we'll set all this aside for the moment. Oh, well, I wasn't checking them against the list. All right, so they call it a spade. That's a little thing that, like a spatula. The wrench, the socket spanner, nozzle cleaner. Yes, that's what that acupuncture needle was. Diagonal pliers. Yeah, a lot of people don't know that. They see what they call a wire cutter. The actual name for them is diagonal pliers, or as old timers, even older than me, would call them. They used to call them dikes. So diagonal pliers, if you hear that, that's what they're talking about. Let's see, some Allen wrenches, the storage card, and one card reader. Wait a minute. Storage card. Oh, it looks like maybe yeah, it looks like you put like SD cards and micro SD cards into the side of this thing, and then you plug it into the USB port. It's a card reader. All right, quick connector buckles. That's within those little bag that I thought looked like some kind of wire management tools. Let's see, quick release claw. That's the other little piece I was talking about. 2 nozzles and Creality sticker ×1. Well, wait a minute now. I received 2 Creality stickers. Score! Okay, so it looks like we've got everything. Now let's set about putting this thing together.
The next day.
It's the next day now. One of my kids got kind of sick, and so I put this aside to go spend some time with her and help take care of her. But I'm back in the garage, and I'm ready to go with continuing on in this project. Now, I had said yesterday that we were getting ready to start putting it together, but I forgot. We actually want to take it apart first. I want to pull some of the panels off and take a look at the power supply to see, well, to make sure that it is all connected as far as I can tell. I also want to take and pull off the cover for the processor board because I'm curious to see what kind of motion controller there is. There was some confusion on whether or not we were going to be getting an 8-bit processor or an 8-bit controller versus a 32-bit controller. And it never was, to me, very clear which way Creality ended up going. I know if they reached certain goals, they were going to do it, but like I said, it was never actually clear. So we're going to go poke around on there. I'm not an electronics expert. I don't really know what I'm looking for, but we'll see what we find. Now, if you're wondering why it's important whether we have an 8-bit versus a 32-bit processor, a 32-bit processor will basically process data more efficiently and faster than an 8-bit will. It's like comparing an 8-lane highway to a 2-lane normal road. Just you can move things down it faster. Not only does the data move back and forth on the processor faster, the processor itself can run at a higher speed or a clock speed in megahertz. Typically, an 8-bit processor will be limited to single-digit megahertz speeds, whereas a 32-bit processor could run in the hundreds of megahertz, although I think motion controllers generally run something like 50 to 100 megahertz. And if you're wondering why I know all this nerdy stuff, well, among my university degrees is a master's degree in computer science. So, yeah, big time nerd. Let's turn this thing over very carefully and see what we're dealing with here. Okay, we've got two plates here. Let's see. Based on the fact, well, I don't know. I figure out which one might be which. Let's see. Where's the power switch? Is that it? Okay, that's it there. So I'm guessing since that's the power switch, that this is probably covering the power supply. And we are dealing with hex head bolts. So, all right, so I hate Allen wrenches. I do not want to use those little Allen wrenches that came with it. I'm going to use something different. When dealing with hex head bolts, if at all possible, I like to use hex bits in my drill. And let's see here. I'm guessing, given this is a Chinese machine, we're probably looking at a metric head size. Okay, that's okay. That's kind of loose, but it's somewhat close. Yeah, that's not a fit. Well, maybe it's an oddball metric size. That means a standard will fit it. That's too small. That's not a noticeably better fit. Well, yeah, it is. That is a better fit than this metric. All right, so we're going with, I don't want to mix them up here. This is the standard. This is a 5/64 bit. And I'm going to use my Festool T15+3 drill. Best cordless drill ever. And I'm serious. You can't buy these anymore. This thing is 11 years old. I mean, you can see it's well used. I've used it a ton, and it's just working fine, just as good as the day I bought. In fact, I'm on the original batteries for this thing, 11-year-old batteries, and they still function perfectly fine. The charge will last, even if I'm using it every day. I can go weeks in between chargings. It's just, this is a phenomenal system. I think the newer model is a T18+3, which I'm seriously thinking about picking one of those up and giving it a try. I think and I think I actually know somebody that I could borrow one from. So that'd be kind of cool. All right, so these bits are magnetic, but I'm looking here and it looks like these bolts are stainless steel, which means it's not going to hold on to them. I've got myself a little bolt holding, the Lord, what are these things called? I don't even know. It's like a little tray, a magnetic tray that it'll stick to like a car or any metal surface or steel surface. And terrific, super cheap, super handy. I think I got them off of Amazon. And regardless, I'll give you a link in the description down below, as well as a link to these bits. I love these bits. They're fantastic. They come as a set of both metric and standard together. I think I paid like 12 bucks for them. They're really, really cheap, but super good. Love them. Okay, let's start by taking off these bolts. Let's see. I don't think, there's a couple of them here. I don't think I need to take these off. I don't know. We'll see. One of the beautiful things about the Festool drills is they use a Oh goodness, what is a brushless motor? So they can run fast or super, super slow. The torque is real controllable. The torque control is amazing. You can dial it down to where it's running really slow with very little torque. That makes it really nice for cinching up small bolts like this with no danger of stripping them out. I'm going to turn the torque up a little bit because I'm taking these out. All right, now let's see. Yes, I didn't have to remove those outside bolts. And indeed, that is the power supply. Okay. A switch looks properly, well, I mean, it looks well connected. I don't know if the wiring is correct or not, but it doesn't look loose or anything like that. Okay, I'm not too sure about these wires coming across on top of this. That seems a little odd, but I guess it's okay. Okay, the connectors into the actual power supply seem fine. There's an adjustment pot there. All right, looks real straightforward. Some people were questioning whether they were getting genuine Meanwell power supplies. I don't see any kind of serial number on this. There may be one in another part, but I'm not going to bother with pulling it out of the machine to check that. Okay, that all looks fine. So we'll put this plate back on. Where did, oh, there it is. Make sure we get it turned. Yeah, see, the wires are running across in front of the fan, which, I don't know. Well, we'll leave it as is. Let's see, these are magnetic. Well, yeah, they're not holding very well. Come on. Because these definitely do look like they're stainless steel. Oh, let's turn that torque back all the way down. Ooh, these little tiny screws are hard to get. Now, let's turn this around and let's attack this cover, which I presume is over the main board. There's only 3 screws. Oh, this is a much longer, oh, that's a very, very long screw. I guess it's trying to reach down into this groove here. Okay. It's not coming loose. It's like something along this edge here is holding it. Maybe it's a flange that pokes into a slot. No, I don't see it. See in here? Fan's kind of blocking the way. All right. Okay, I'm guessing there's probably a screw coming from the other side holding like this side here of this panel. The panel bends down. Let me carefully turn this back over. Okay, now I'm lost. Which end was I working? Ha! Okay, it's going to be along here. Slide the bed back. Yep, there it is. I'm sure that's the screw right there that's still holding on. Nope, wrong way. Yeah, I think I heard the panel fall off. Yeah, I see it laying on the table there. All right, come back. So I presume that fan is connected by a cable. Yes, indeed it is. Let's lay that down. All right, yes, we have a processor board. All right, let me move the camera and give you a better view of what I'm looking at. Okay, so here we're looking at the main board. I am in no way an electronics expert. I can recognize a fuse when I see one. And here are some connectors for wires that are going off to, those may be coming, okay, that's, if I had to guess, those are the main power lines coming from the power supply. Here's a fan connector. This is a fan 2 header that you could attach a second fan. Okay. This is the SD card slot over here. Some chips here with heat sinks on them. Those could be the actual stepper drivers, I'm guessing. Right. So logic control headers there. Okay. Okay, here we go. That is an ARM chip. That's ARM is a processor manufacturer. And yeah, I'm guessing that that is the motion controller. It says STM32F. Now, I'm no expert, but I think that 32F means that this is indeed a 32-bit processor. That's good. That would make me happy. Okay. Here's some sort of a slide. Oh, that's a USB. Looks like a USB-C maybe connector coming off the board. And that is the limit of my electronics knowledge. I did have a class in college involving wiring electronic components, building logic circuits and stuff, but at a much, much lower level than this. Component stuff I've never really done or been interested in. Okay, I think that's about all that we can learn from looking in here. Looks like we got our 32-bit motion controller. So let's button this back up. Need to get this. This is the little tab that sits down against the top of the base and where that other screw goes through it. So we need to make sure that that doesn't get trapped in these wires here. All right, that looks good. And let's see, well, let's see here. I forgot to look at this. Yes, the screw hole is down in this groove. That's why the screw is so long. Let's set the two front ones first. Help align that back one. Not tightening these up completely. Well, crud. I've got an extra, oh, no, that other little screw is the one that goes into the top side. Okay, I thought I had messed up and had an extra screw. Not like that's ever happened before. Okay, it's going in fine. You see the way I can slow the drill way, way down when I'm getting towards bottoming it out. Super control. Come on. Oops. It's kind of jamming in these things, I guess, because it's not a real good fit. Okay, so let's put in that other bolt through the top. And we should have this thing all put together again. Where is it? Ah. It's a little tricky. It's right up against that rail. Okay, good. I was worried about it catching that tab under there if the tab wasn't fully pushed up against it. I guess it was because it caught no problem. You know, so I just realized something. I wonder if this is a dual voltage power supply and what it's set to if it is. Dual voltage means that it can be fed with either 240 or 120 volt power. And sure enough, this is a dual voltage and it is set to 230 volts. 230, 240, it's basically the same thing. I guess the point is that these were all being shipped to America and it wasn't set correctly. I wonder if that's the problem. If the machines are coming in and people are not setting the voltage. No, they said it was not a user error. Okay, regardless, I'm going to go ahead. It probably says it in the directions, but I'm going to go ahead and flip this over. There's like there's a little slide switch hidden in here, and you just push it to the other side where it says 115. Again, 115, 120, it's basically the same. All right, so we are all buttoned up. We checked all the connections. We think they all look good. I looked at the main board, very happy to find what I believe is a 32-bit motion control processor. And so we are now ready to actually put this thing together and hopefully start making some stuff.